or not?
Yeah, it's okay if you don't feel like
Okay,
it, but
right.
do stop us and ask us questions and tell us stuff. I think we prefer that more than we need to see your face.
Oh, nice. Matches the background. All right. Perfect. Do you want to kick off the presentation?
So to revise a couple of things, what we did from the first day. So what we did on first day, we focused on data generation, and we had two streams in which we were focusing on. The first one was visual data generation, which we did it in Grasshopper 3D. We had a script which was solving our design problem, and then we used a couple of components in Grasshopper like generator, uh, concat, as well as data recorder to record and to generate and record our data, and then export it to Excel, and then save it as CSV for our model training. The other stream was data generation via sketching. So the basic approach was you are given an application and you are asked to sketch your building footprints in the given context, and then you save the image data, which will be used for the image classifier algorithms. And a couple of you even suggested that uh, you want to focus on some other softwares like Concept or Photoshop to generate that image data. Then the next day, yesterday, we focused on machine learning model training. So we learned a couple of basic terminologies and how to get started in Python. We use Google Colab and we use linear regression for that. The other stream focused on image classification, where we used Google's teachable machines and we uploaded our image data in it. We trained our model and we exported it. So I asked you to save that link of your personalized model. So when you had a personalized data, your model is also personalized. The algorithm is using your data, and the link will also be used to create your own applications. And for the linear regression in Google Colab, we used a library to convert our Python's machine learning code, the fit function. We converted it from Python to JavaScript, which will be used in application today. So I think Arifin will start with visualization today, and then
Hey
we'll
guys.
jump into demonstrations.
Sure. So Rutvik will share his screen because Rutvik is recording for other participants, and I'll just look at the same copy on my screen, and I'll ask you to change slides.
Yeah.
Cool. So let's get started with the first slide. I'll wait for you to put that up.
Okay. Is it visible?
Yeah. So day 1, day 2, day 3, visualize and share online. So starting with visualization, the next slide, please. What is visualization? If a picture is worth 1,000 words, then a visualization is worth 1,000,000 numbers. So, but why though? Well, because numbers to us are symbols. A 4 is a bunch of strokes, and in different languages, 4 is represented in different ways. But we are visual thinkers. These symbols, they don't have any meaning without their context. So encodings like bars, plots, axes with elements such as height or scale or size, area, direction, angle, color intensity, or the node link relationship in a graph. These are what give meaning to symbols, which are numbers. So going by another analogy, if you think of data as the ingredients, data by itself has no meaning to us. If I show you a spreadsheet, there's so many numbers you don't even know what it's telling you. On the other hand, visualizations such as bar charts, pie charts, scatter plots, parallel coordinates, These give us the insight to the data. Like, it helps us find meaning. So think of data as the ingredients, the numbers, and the visualization is the cake. What you get from the what you get is meaningful from that data. How do we visualize results? Well, I don't know what this means, but here's an example of how, like, as you can see, the height of the different bars and then the color intensity, these have like encoded in them the numbers, the so-called like data, and that is telling us, okay, there's some kind of, like, I don't know whether that is talking about density or whatever else it is, traffic at a certain time. So there's one example. Then next slide, please. Here's an example of what we use in DBF. So if you remember, we generate options and there are certain key statistics. And then, so here's the first row is obviously the representation of the object itself as a 3D model. And then the second row is raw numbers. So raw numbers will help us find exact values, but it doesn't help you compare the values with each other. But if you go to the next row, the bar charts, see, that's where these comparisons become apparent. Like, the length of the bar charts can be compared and you can get an idea that, okay, this one is higher, that one is lower in comparison, in context. So that's why, again, if you go back to the row with the numbers, like the number FAR 3.4, it doesn't have any meaning if you just know the number 3.4. But if you look at it in the context of others, then you know that, yes, this is a high or a low FAR. And obviously, the last row is the share. So visualization, like encodings, like pie charts, they give you a share of the overall, like, yeah, the overall distribution, like how much is it out of like a number of other things. Okay, so the next slide, please. So this is another complex visualization. Here you see there's like several visualizations combined, and there are like actions that you do that help you further extract further details. So it's sorting the data, it's applying color by a certain variable, then that action, like drawing a lasso around it, it's saying that what is it that is between these ranges of whatever variables that I selected. And the style of the visualization itself, as you can see, it's known as parallel coordinates. This visualization is good for giving you an overall picture of a large data set with many variables. Like, if you think of the simplest graph, x, so we talked about y is equal to mx, and you get a line which tells you the relationship between y and x. But then if you have a, B, C, D, 26, let's say the entire alphabet, how will you even imagine, like, how many dimensions can you visualize it? You can't. So then you use something like this. It takes those dimensions and makes it readable to us in a certain way that lets us derive insight from the data. Next slide, please. Oh, okay. Yeah, you can. Oh, here's another one. This is the graph or node link diagram. This is more about relationship between entities, and the density tells us, like, I don't know, what is this? WebGL Kepler, okay, by Uber. So I guess like this is what, road networks. And then at the bottom, you see how there's another visualization, but that's also interactive. So time may be another dimension.
I think these are flights.
Oh, okay, flights, cool. So time may be another direction, dimension that may be encoded with interactivity. So like you get a picture of what it is at a given time slice, but then when you move the slider, the time changes and patterns become apparent. And then again, see, that's the visual pattern that we're looking for to help us decide or gain insight. Okay, next slide, please. So here's an example of, I forgot what this was. Is this Proving Grounds?
Yeah, it's semantic by Proving Grounds.
Yeah, okay.
Power BI.
So We as architects are faced with a unique problem. Problem is, like, we're not happy with numbers alone. Like, we also need to see the artifact or the design itself, and which can be represented as a plan or a 3D model. Can you think of any other ways of how you would have your designs represented? It could be a circulation pattern, etc., etc. So we need these different representations to come together, and you should be able to manipulate these together. Here's one example. Like, as you can see, they're selecting a certain type and it's changing, and they're also able to manipulate the 3D model, and you see some of that encoding that I was talking about in the 3D model itself, through color. And another example is the next slide. um, this is very popular. You can play this, or you can access the link. The presentation is shared with everyone, I guess. So in this example, like, again, you have multiple. Oh, okay, sorry. So welcome, Jalen. So we were just talking about why we need to visualize, and an example right now, the example that we're demonstrating right now tells us, like, we as architects need to see so many different aspects of our design, the design itself, and data associated with it in several different ways to help us decide. And this is an example of how, remember how we were talking about inputs and outputs? Like, you abstract your design problem into inputs and outputs, and those inputs and outputs are what we use as data for our for training our model. This is a very effective way of visualizing that data. So the parallel coordinates on the top, they are your inputs on one side and outputs on the other. Can you play that again and pause it for a second? Yeah. So
Yeah.
outputs on one side, inputs, and they're just trying to, like, filter data points and trying to like, manually understand relationships with them. So what they did right now, they said, okay, what outputs are we getting? What is the trend in outputs? Or which directions do the line in which directions do the lines flow if I narrow my input to this range? So what it is actually doing is, it's also behaving like machine learning. They're trying to find a relationship between inputs and outputs manually. So machine learning helps us with that, and we need to visualize it at the same time. And these are some examples. And why do we need to use external tools? Well, because if you think of the tools that you use currently, none of them actually give you these capabilities, which is why there's so many examples out there. We have to make our own. And with that, we can get started with P5 JS. So Rutvik, you want to start off?
Yeah.
Start off, and then
So what we'll be demonstrating today is the method or a way to build applications in one of these visualization tools. So what we'll be using is a visual coding platform like P5JS. So I'll just give a context of what P5JS is. So as someone yesterday said that it is based on processing, and processing was started at MIT Media Lab by art students, so that coding is more accessible to the people who are in design industry or creative fields such as us, like architects. And what processing used is it builds the application in Java programming language. But if you see today, all the applications which have a very cool front end interactive and dynamic elements such as sliders, or when you hover the text changes, or some of things like this. So the programming language used for such application is JavaScript. And so some people decided to build a platform, or a, you can say they built a project which is based on JavaScript programming language, and it has the base of the core principles of processing. So what P5JS is actually is like building applications in your web browser. So what we'll be using is P5JS web editor. We'll be building the applications in your web browser. You don't need to install or download any kind of softwares or web editors to build it, and you can even visualize it side by side and even share it online. So as I said yesterday, that why is visualization important is because you know what's happening in machine learning, you know where the data came from, you have done the analysis, but when you present it to someone, the person in front of you, say client or professors, do not know what was the process of this the process of this analysis or machine learning algorithms. So we are going to use P5JS as a platform to create applications which can be shared to people who are non-experts, and even it's for you to understand relations between couple of things and visually understand the whole summary of your process. Okay, so let's get to demonstration. If
So
you
sorry, does anyone have any questions regarding visualization or anything?
Yeah, please go ahead.
Okay,
No question.
let's go ahead. Yeah.
So I think need to shift the presentation screen. So if you go to your lab notes, the first example, first demonstration I'll be demonstrating is of the yeah, I think you can see my screen. Okay, so the first example I'll be demonstrating is of the footprint classification app. The stream we are focusing on is the manual sketching. So we sketched a couple of footprints, we stored them.
Hang on, real quick, 1 second. Let's just quickly breeze through P5JS for a second. If you can pull up the lab notes and go to page, what page is this? We're at.
Can you share the link to the lab notes in the chat also?
Yeah.
I'm trying to. Yeah.
Okay, you did, or I should?
I can. Or you have it. Okay.
Yeah.
Great.
Okay, so going back to the lab notes, and why doesn't it tell me the page number? So day 3, visualize and share setup web page P5JS. So yeah, just click on the thing on the left. So just to make sure we're all on the same page. So what it does is, yeah, can you scroll down a little bit? So just there. So it's basically broken into two functions, two main functions. And why am I not being able to zoom in? Sorry, give me a second.
Just open another P5JS web editor for explanation.
Okay, so when you start, you're given with this. You're given this setup where there's a setup function and there's a draw function. So what happens is, in the setup, you do stuff once, and then the draw function happens, like it's being called repeatedly. So anything that needs to be repeated, let's say if it's a transition or an animation, that goes in the draw function. So in this one, the most basic setup, you create a canvas and you give it a size. It's 400 by 400. Obviously, it can be bigger or smaller. And then what you do after that is you say background 220. Background here means background color, and 220 is the value. So once you're done, you have to hit play and the code executes. So 220 is it's gray because on a scale of 0 to 255, 0 is black and 255 is completely white. It's pure white and pure black. And then, of course, if you add more numbers, so those are basically R, G, and B values. So this is R, G, and B. So the first number is R, the second number is G, and the third number is B. So because you have like 255, it means a full blue. And if you change that to 0, what you will get is a black, because 000 is black. So if you enter equal numbers, you will get shades of gray. So Ruthvik, go ahead and enter like, I don't know, 135, 135, 135 or something. Or yeah,
Okay.
something like that.
Also, it can accept hex codes and other forms of web colors.
Yeah.
Let's stick with RGB for now, unless of course everyone knows what hex codes is, and then I'm just oversplaining stuff. So anyway, so that's gray, and then you can guess if you want an R, then you would have to make the first number a 255,
255,
and the
yeah.
other two numbers would be 0 and 0. And can we move to a slightly more illustrative example?
Maybe I can draw an ellipse with mouse X, mouse Y.
Okay. So what happens here is the canvas has already been set up, the size given, and you can also change the background. So the background is something that need not be changed. The background color stays constant. So you can put background in the setup function too. If you had something like change the background color continuously, let's say like with every frame, like you increase the numbers. So every time the function is called, it will, let's say you ask it to increase each of those values, which are at 125 now, you increase it by 1. What you would see is a gradual, well, not gradual, it will be quite fast. It will go from black to white. So that's what it does. Now, what Ruthvik has done here, he said the draw an ellipse, so the ellipse takes in 4 values. I'm guessing, what is it? The
Okay. Yeah,
X,
just
Y coordinates, and then the radius.
Okay, yeah, X and Y coordinates based on the canvas. And by the way, here X and Y, they start from the top left. So the top left is 0, 0, 0x and 0y, and the bottom right would be 400x and 400y. So that's how it goes. So it takes the the x and y, the center, and the major radius and the minor radius. Because we entered 50 for both, it's a circle now. So Ruthvik, for a second, yeah, can you cut the ellipse function and paste it into setup?
yeah.
And press run. Okay, and like also cut the background and put it like before the ellipse, because I think it's being.
I think it's good to explain though why you can't see the ellipse right now.
Yeah, so what happened was the setup function is always called first. That's the first. Think of it as the first draw, and then nothing happens. It's just done once. And then draw is repeatedly calling a setup. That's why it's called draw. So what happened was when you set it up, it created a canvas, then it drew an ellipse. But then in the draw function, which is the subsequent call, the background was colored over. So the sequence is important here. So now you don't see the ellipse. You saw it for a second, it disappeared. So Ruthvik, go ahead and cut the background function and paste it before the ellipse. Okay, and hit play. So right now you see, like, first the canvas was created, then the background was set to this shade of gray, and then the ellipse was drawn. But the ellipse doesn't move because it's been called once and it's set in stone now. You can't change it. To change it, you have to redraw it, and you have to provide the logic for redrawing it. So now just cut and paste the ellipse command the way it is into the draw. And
change it back to like mouse X, mouse
No,
Y.
hang on. Let's just go with this and
okay.
Yeah. So hit play. Right. Okay, well, you can change that, but hit play. So now move your mouse around. So can you guess why it doesn't change? The answer to that is you use constants. So it is drawing the ellipse over and over again, but it is using 45, 45, 150, and 50. You haven't supplied a variable that's changing. Now, if you switch the 45, 45, which is your center, to your mouse X and mouse Y, which always changes, that variable, the system always updates mouse X and mouse Y according to where your mouse is on the canvas. See, now you draw it. But then why do you see this over, like, what is it called? Like the redraw,
Overlapping.
yeah, overlapping. Why do you see it? Well, because we haven't told it to clean the background. The background is set to 125, 125, 125 in the setup once, and then it's forgotten. No changes to the background occurs, and the ellipse is just being drawn over and over again. So can you guess what we should do to have the ellipse move around with the mouse and the background be visible? Anyone want to take a shot at this?
Put the background in the draw.
Awesome.
Yeah.
But where?
Before the ellipse.
Awesome. So thank you. So Ruthvik, can you quickly do that?
Yeah.
Play, and there we go. So that's the basics of P5 JS and also processing JS. P5 JS is just the JavaScript version of processing.
Yeah.
So
and to explain a P5 project, I have an example through which you can understand it more clearly. So a P5 project has three files: index.html, sketch.js, and style.css. So if someone is not familiar with front-end development, web development, so what these three files do, I'll explain it in context of architects. So think of this project as a building, and the HTML file acts as a structure of the building. The CSS file acts as a interior and exterior decoration, like the facade decoration or interior paints, you can say. And sketch.js, which is the JavaScript file, has the interactive and dynamic elements and functions, like what we had is moving the ellipse or drawing the ellipse. So in building, you perform certain functions, like the occupants perform certain functions. So think of yourself as the occupant, and you're performing certain functions inside the building. So what that is, it is the sketch.js file. So
It was a beautiful explanation of a website, Rutvik.
fantastic, Ruthvik. You're slated for academia.
Yeah.
Okay, so I have mentioned all these steps to get started with P5JS in the lab notes. So first of all, you need to uh, sign up for P5JS. It's completely free and web-based, so you can just sign in with your Google account or any of your mail IDs, and then you'll get to the basic code which was provided earlier. Like you had this setup, create canvas, and draw background. And if you are all on that page, then we can proceed to further our applications demonstration. So the left side we code it, and on the right side we can see the visual explanation of our code. Like we can visualize it.
Yeah, and basically the reason we're using the editor is so you don't have to worry about the HTML and CSS for now. You can just focus on the visualization part. But when you're done with this, it's basically ready to put on a website. Like it will be a website.
Yeah. Also, you can share it. Like I have shared my code in a certain way. So you can just go here in the file and click on share, and you have certain options like present, full screen, or edit.
Oh, yeah, iframe.
Yeah, so I shared the edit share option with you, so you can even edit your applications. Okay, so the first application we'll focus on is the image classification one, the footprint classification. And I'll explain in a brief what the entire script is doing and what certain functions are doing. So first of all, we need
So
to...
just 1 second. It might seem like we went from just moving a circle around to this, and it might seem like a huge jump, but bear with us, and we will explain it line by line to you. And then also, like always, as always, just stop us and ask questions if you're lost.
Yeah, and I think for your visualization too, we know it takes a lot of time to learn JavaScript and P5 JS, so we just want to give you an overview. And then today or on the weekend, if you want to help with your visualization, as long as you have an idea, we're happy to help you code it up if you have any questions. So don't feel like we're leaving you like alone. We'll be here with you every step of the way.
Yes.
Yeah.
So to start with the JavaScript function of our application, we first of all need to specify the variables which we are going to use. So what we are going to use is canvas, classifier, and vertices for editing the polygon. And then is the image model URL, where you need to paste your own unique teachable machines link, which I told you to save it when you trained your model yesterday on teachable machines, and when you clicked on update or upload my model, it created a unique links like teachablemachine.withgoogle.com and /models, and you had a unique code here. So for your own image classification application, you need that your own link, and you also need your own background for that. If you have some other, like some of you focused on satellite images, or some of you wanted to create the background or the maps in some other softwares like Photoshop or Concept. So for that, we'll specify the image variable, and we'll load the image here. So I've even added that in the lab documents, where you can change the background image. To change or upload any image you want as a background, you need to go to the image file. You click on upload file, and from here you can simply upload your files, like whatever background you want. And then whatever name that image file will have, like my image file has the name test.jpg, like I want this as my background map. And so you can see the name here, images/test.jpg, which is the background image. And the major function, or the major uh, code chunk which is useful for us is the yeah I guess okay. Yeah, so this one is important to us, where we are going to be using, for the image classification, we'll be using another library which is called as Ml5 Js. So to give a brief context of Ml5 Js, Ml5 Js is a JavaScript library uh, with an aim of making machine learning accessible to visual learners. So whatever tools we are using are very beneficial for visual learners, or creative coders, or people in design industry, where the major focus is on visualization rather than getting too much into coding. So what ML5JS does is it has a built-in library in P5JS, and it calls the pre-trained model of image classifier. And the data we'll be using is our own data, right? So the model is already trained. We'll be using that algorithm, and the data on which our algorithm was trained is the teachable machines link. So first of all, we'll be using ML5JS for the image classifier algorithm, and our own trained model will be exporting it to P5JS via that teachable machines link. So as I said yesterday also, that the teachable machines link, this link is very important for your own personalized application, because this link is unique to you, and the application I shared has my link in it, right? So it will be my application, and to make it your own application, you need to change that link if you have chosen the image classification stream of generating the data. And the next step is we add buttons.
Hang on real quick, for 1 second. Let's ask the participants if they understand where we're going with this. Do you have any questions? So
Yeah, I have a couple of questions.
Sure,
One
please.
was a distraction. I missed was what the variable D was. Yeah. What's the variable D at the top? I missed what it is.
Okay, the variable D.
I
At
think
the
it
top.
doesn't.
At the beginning.
Oh, I don't think it does anything. I think I forgot to delete that line. Sorry about that.
Okay, and another question: why you define in line 13 twice the classifier? Why you use twice the equal sign? Is it just a syntax or?
Yeah, it's
Oh.
just the same thing, I guess.
Yeah. Oops, sorry.
So if you have seen
Okay.
that it didn't change anything, we specified classifier is equal to classifier is equal to ML5 image classifier. Still, it was running the application. So that's also an interesting
Clear.
part of P5.
Clear. Thanks.
Yeah.
Okay, thank
And
you.
whenever you have any error, you will just see something like if I what do I do? Yeah.
I
So
put a
you
comma.
see,
Yeah.
you can
Oh,
see
yeah.
a highlighted yellow highlight on the numbers on which the P5JS editor found any error. So for that you can, yeah.
So so what we're doing here is we've already trained our models, and the classifier variable holds that model. So when we say classifier is equal to ML5 dot image classifier, and we tell it where that model is. So the location of the model is with Google. So there is a web site, basically not a site, but it's a link. It's known as a URL, Uniform Resource Locator. So if it's just know that stuff on the web is always associated with a URL. But we train the model using scikit-learn, right? So how do we? If we kept using Python, the same libraries on our computer, we wouldn't have a problem. But we are trying to see what the model predicts by making our own visualization tool, right? So how do we get that model here? This is how we bring it here.
So
There is this library.
basically you are exporting your trained machine learning model from the teachable machines to the P5JS web editor through this link. So think of this link as a bridge between the 2 days model training and visualization.
So not just your model, which is a JSON that you made. So the model data is, and it's a black box. You don't have to bother about what is in that JSON. All you need to do is train it and bring it in here. And what the model that you trained using the image classifier, teachable machine, that too is located in Google's ecosystem somewhere, which is in that URL. And that's you're just importing it. So it's just an import. That's what it is.
Yeah.
Okay, go ahead.
So we load the background image with the load image function, and the next step is we create buttons. Okay, so we created a button and we named it like, what should the button say? Make prediction. And we specified the position of the buttons. So as Arafin mentioned that the X and Y start from the top left corner. So this corner, if you can see my mouse, and from there we specify 8 as X and 65 as Y as the position of your button. Okay, so the next function is mouse pressed. So what mouse pressed does is whenever you as I said, the JavaScript has interactive and dynamic elements and functions which you can interact with. So one of them is mouse press. So whenever you click on make prediction, it does certain things. And what it does, so I clicked, so you can even see what it does. In
So first off, the button is just to trigger something. That's all. So we don't want it to keep running automatically or run once and disappear. That's why we said, okay, let's have a button for this. You can assign any function to a button. That's why we made this button. That's it. The main thing to know is that we told the button that every time a mouse is pressed, do this, and that this is what the new shape does.
Yeah. So we have added two buttons. One is the prediction and one is the new shape. So we have even specified later in the script what these two actions will do. So the action for this button is predict, and for this button new shape is new shape. We'll see what it does. Okay, so you set up the canvas and you draw the background image. What you did earlier was you loaded the background image. Now you will draw the background map for your canvas. The next step is you draw the polygon. So what I thought of this application, like how I wanted this application is to be uh, the data was generated using sketching, right? So I wanted that sketching element in my application as well. So we create a polygon, we assign a default position to that polygon, and if you go through the function like the edit polygon function, you can even edit this polygon by double clicking on the vertices of the polygon. You can change the number of sides by skipping one side, like, yeah, so it changed from 4 sides to 3 sides when I uh, dragged my mouse click using the vertex. So that's what the function is doing. The edit polygon is doing the changes in the polygon, and that's what I wanted from this application. And you can have certain other things, like you want some hover, or you want some different interactions you want in your application.
But like, what
So,
happens when you click on new shape?
Yeah, so if you go to, yeah, new shape function, when you click on new shape, each time you click on new shape, random polygons are generated uh, in the specified location. So the location of the polygon is fixed, and every time you click on new shape, a random polygon with random number of edges is generated, and you can just change the number of edges, like going from here. And
so to summarize, this is nothing but the sketch tool.
yeah,
This is the sketch tool, and the only addition is that the model is already trained. So now you have the model on standby, and you're drawing stuff and then asking it to predict what it is. And just a little bit on the code. So like, remember how there was like a setup and a draw? So there's still setup and draw. It's just that there are many more functions to call within that setup and draw, which is why it seems like there's so much code. But if you actually look at the setup function, it's just 3 lines. And if you look at the draw function, it's just, I don't know, like 6 lines. So in the setup, first we create a canvas 815 by 815. So I'm looking at line number 36. That's strangely 35 on your end. Okay. So create a canvas, then load an image, and then no stroke is just saying that don't draw lines. And then in the draw, like, keep drawing the background image first. Fill, meaning color it with this color, color value of the polygon. It's already there. Begin shape, and then vertices for each. So you already have begin shape and end shape. Wait, what will it do? It'll draw the random shape, right? No, new shape draws a random shape.
Yeah.
Right. So can you explain what begin shape and end shape does?
Basically, remember how we had the ellipse function? To draw a polygon is a little bit different in P5. So polygon and shape are kind of the same thing. So what you need to do is you say begin shape, start drawing polygon, and then you list out what are all the vertices of the polygon. So say if you had like a pentagon, you would just list out all the points in the pentagon, and then when you say end shape, it will close that shape and fill it in with a color.
That fill is just specified above it.
Yeah.
And
yeah.
So you can see that there's begin shape, and then there's a list of vertices. And what it does is that for each vertex in that list of vertices, so that's what vertices dot for each means. take each vertex, and then take the x and y of that vertex and put it into your shape. And once you've gone through all the vertices in that list, just close the shape. And where are we getting these vertices from?
New shape.
Right. So it's from new shape. And how do we get a new shape? When we click on that button.
Yeah.
We can click on that button, we get new shape, which makes a random new polygon. And so, sorry, a new shape will just generate a bunch of vertices. And then the draw function is called repeatedly, remember? So immediately the draw function will start drawing that, and it will encounter begin shape. Then it will look for the list of vertices. We've already specified where they are, and then it will draw that shape. And then immediately what it will do is it will call edit polygon. And edit polygon just listens to your mouse movement and your mouse clicks and makes changes to that list of vertices that we generated randomly. And as soon as you move your mouse around, add or subtract points, the draw function immediately the draw function is being called repeatedly. So it will again do it. So that's how you have this like animated. Think of animation happening many times a second. So that's basically it. That's what it is. And then the drawing is happening continuously. And then once you click on the make prediction button, remember make prediction, the action was the predict function. If you go down to the predict function on line 76, what it does is it gets the image actually this time. So remember when you were drawing these images using the sketch tool, this was the background. So it's the same, like it is an image. It's a new image every second. So no, actually more than that, depending on your frame rate. So that's what it does. If you look at line 77, it says image equal let image equals canvas.get. So it just grabs that whole image, and we've already trained our model. So it's saying like classifier, which is stored in the classifier. Then it's just saying, hey, classifier, here's the image. You've already been trained. Can you predict what this is? And that's it.
Yeah. So basically, these all like whatever we spoke about the edit polygon or the predict, these are all the action functions which you're specifying in the buttons, right? So here you said whenever mouse clicked on the make prediction button, it should do the action of predict, and then we specify the action to each and every function we have assigned to the buttons as well as to mouse clicks. So it may seem a lot of code, but it's not. If you break it down, it is just like drawing a background, then adding a draw function. So adding certain polygons, like one polygon we wanted, and then when we specify the actions of the buttons we have specified earlier, right? So what predict does is it makes prediction. And one thing you should always take care of is like in this model, the data we trained, like the data we generated on the first day, we created a polygon and it was of different color, right? It was not black and white, it was a different blue. So that blue was of this hex code, and you should always remember that the color of the polygon is same as the color of the data. You cannot change it, or else the machine hasn't seen that color earlier, right? The machine has seen this color, the machine trained on this color. So whenever you're giving a input for it to predict something, it should be of that color, or whatever color you specify, or whatever features you specify. So I think this is what the function is doing, and at the end the function is get results, and you console log. So if there is an error, what console.error does is it shows an error, but if there is no error in the code, you will see no error here. But if there's any error, you can simply check it by adding this code if error. And JavaScript has this parentheses, curly brackets. You should specify for each and every function. And at the end of the code, you should always add a semicolon.
No, you don't need to do that actually in JavaScript.
Not anymore.
It's a preference. It's a preference. Yeah.
Okay.
It's a thing people argue about.
Okay. And
Yeah.
then the last step is you add your customized line for the prediction. So what results you want. So I said like, okay, my and then the percentage of the confidence, the percent you were getting yesterday. If you had seen, if you went to the preview section and you added some of your own images and checked the percentages, if I have it, yeah, so you can see 34% residence and some odd percent school, 63% commercial building. So that's what is translated to this code as well, using the results, what do you say, the bracket 0, that means the first value of results is the percentage of your accuracy, and you add into 100 for the percent to not to be in the decimal value, and you add this line. So it's not difficult. It may seem difficult, like there's a lot of lines, 114 line code, and it's a huge thing, but not if you start with basics like we showed you. And if you're thinking how we jumped from drawing a ellipse to this application, it's not that difficult. It's just like you need to know whatever buttons you are assigning, whatever interactions you are assigning, needs to have some functions, action items in them, and those action items are the functions.
Yeah, and also like don't feel bad if you're confused by JavaScript. We were all like super confused when we started learning. So just take it step by step. And also we're here. So when you're working through this, we're here to help you answer any of your questions. But just give it a shot. Like just take the first step.
Yeah.
Essentially. Yeah.
Yeah, you need to start to
Yeah.
get any, and it's really not difficult. Also, if you hesitate to ask us questions, there is a beautiful documentation as well of P5JS, the get started documentation. I've added all the links in the uh, lab notes and the reference file
Yeah.
as well. And
Oh,
it's,
and maybe one more thing. Show the website open processing. So open processing is like the P5JS community. So I use this in my teaching a lot, but there's like literally like tens of thousands. I don't know if you can see. Go down. There's like tens of thousands of example projects here to inspire you with the code. So one option also is to look at some of these example projects and find one that kind of relates to your project and use the example as like a kind of inspiration of what you could do.
yeah, and even the P5JS documentation has the examples,
Yeah.
which has all the open source code available, like redraw or whatever functions I was saying, the action items. Each one of them, they have tried that each of the function has certain app created on that, and the code is available. You can simply click on it and check anything, like by going to web editor. See, the code is available. So that's not an issue. You need to think of an idea. How will you create the application? What all interactive elements it will have? What all buttons it will have? How the text will be? And once you get that in your mind, you can simply refer to tons of ideas and codes available there.
Yeah. Do you want to show the other example, Razvik?
Yeah. I'll start with the coding part. Yeah.
Maybe,
Okay.
I don't know if you can fix the zoom on your screen so you can see the app. Yeah.
Okay. So
I have a question.
Yeah.
Why you define the variable outside the setup? I was expecting that you put the variable inside the setup.
This has to do with variable scope. And so
You always
don't want to
define
get
it in advance.
Well, some variables are called global variables. So anywhere in the code, you can read it, but if it's inside the function, it's only readable inside the function. If that makes sense.
Yeah. Clear.
Okay.
so like
Yeah.
we wanted to
we could
use
spend we could spend like 10 hours talking about this, but generally that's the idea.
So for the global variable thing, we wanted to use classifier in multiple functions, right? So that's why we specified it before the setup and not inside any of the functions or setup.
Clear.
So here's another example looking at like a 3D visualization. of the daylight autonomy code. Did you show that yesterday, Redvik,
Yeah,
in
yeah.
team?
The demonstration in Python was based on the daylight autonomy.
Okay, so basically here it's the same thing, but visualizing the volume of a room and predicting the daylight autonomy score. And so you don't just have to do a 2D app, you can do a 3D. Okay, that's all I wanted to say. Rodvik, you can dig into it. Maybe just show like if you change the sliders, it will change the color of the volume based on its daylight autonomy score. So you can see the relationship between the different parameters and the
Yeah, you can
yeah,
check
yeah,
the average daylight autonomy for a given room
yeah,
is. You don't need to manually input the numbers. Like that can be an option of
yeah.
input. Like input can be via text or it can be via buttons or even sliders. So here we are using the sliders, and for that the function we are using is create slider.
Hmm.
So you can even check the box, like how is it changing. Like it's very nice to visualize these things and present it to someone, saying that this is your application. So here we
Hmm.
got that wrong, right? Daylight autonomy is from 0 to 100, but we know that, like I said, that there are some samples which might lead to some predictions which are not in the range of your output variables. So the daylight autonomy is from 0 to 100, but since our data was specified on certain part of that range, here it's predicting wrong.
Hmm.
And another thing about the conceptual overview of why we're doing this is, well, this is just one way. So if we take the example of the sketching tool, because it was so easy to make that sketching tool, we just replicated that in this, and or think of it the other way. Like we had that sketching tool, it was already made in Ml5 Js, and we just found a way of linking our trained model to that application. So earlier we were just sketching, now we have a trained model, we were sketching and getting it to predict what it is. And the sketching tool is our example. Like you can have specific needs. Like maybe you're generating the, I don't know, the footprints in Grasshopper, like based on some constraints, some offsets from the side, some curve division, and then like now how do you, now once you have made your predictions, like sorry, once you have trained your model, like how do you like, present it in a way so that it's easy to understand for others, and you also, like Ruthvik was saying, you document the process. Like, okay, I trained this model, look at what it does, see it is predicting what I need. So that's where you have to like think of how to like visualize and make it interactive if you want it to be interactive. It doesn't have to be interactive too. Like in many cases, you just train the model and then you just output the data and you just work with that data. But I think for designers, most of the time you will have to visualize the data.
Yeah.
So that's where we are getting at with this. Just don't get too caught up in what's happening here. We want you to start thinking about how you might need to use visualization based on the problem that you defined and the model that you trained.
Yeah. And
Yeah,
for
I think also one thing is we're just visualizing like the output of like one model, but when you have like a more complicated design problem, it's okay to mix and match your approaches. So maybe you have 2 or 3 models you're using, and they're using some sort of like another algorithm that's putting them all together. So you can make something more complex out of these small pieces, rather than trying to have one model that does everything, if that makes sense.
And in the last example, we were using the Ml5 Js library to bring in the machine learning code. So that was another approach. And for this, since we didn't use teachable machines for this approach, we used the Python hardcore programming language of machine learning. We used the Python language. So I told you how we can use that code in JavaScript. So we ran that command, which was M2 cgen library, which converted the Python code, and it gave you a certain function, right? So here is that function of linear regression, and you add it in your score function. So your score is like just acting like the predict thing in the last one. It's calculating the score, and the predict is visualizing the score in form of, say, sentences like this. So I think with this, we'll move to the exercise, and don't be afraid that it's not at all hard. And the tutorials, the getting started videos on YouTube, the code community, they're all very helpful, and you can get like each and every, you can create your own high-end application with all the code available. So no need to worry about how will I code. You just need to have that idea of what you want in your code.
So Patrick, what's the, or like Aravind too, like what's the best way to get started? If I have a project idea, but I'm not so strong on programming, like how could I get started? What was my first step? Should I just start coding?
I think you should start with simple examples that are already there and start modifying that code to suit your purpose. That's the way I learned. And it's also kind of recommended in teaching. I don't know, it could be something else for others.
What about Ratek? What do you think is a good way to start?
So whenever, like, for creating such applications, what I do is, even I'm new to P5JS, I just learned it a couple of weeks back. And what was my approach is I went to YouTube, I searched like, okay, how do we add a score button? How do we add a predict button in that? And then I just started, like, you will never get a exact thing or exact code or exact video for your own application. So you need to tweak it, change it, and see, like, if you change a couple of functions, say slider position, slider values, you can see that changing. So that's what is the advantage of P5JS. So whatever you do, whatever changes you do, you can simultaneously see them, and then by lot of iterations and lot of learning, you will get to a position where your app will be like very useful for you as well as others.
Caesar, what do you think the best way to get started is with a project like this?
I mean, I think it's two things. First is getting a clear idea of what is it that you want to do. And for me, what's helpful is like take these examples and then start changing little things, and then that could inform what a process for what your own project is. So let's say here, one little function that you could add to make this interesting is changing the color of the box once the prediction is more than a certain number or less than a certain number. And that would be very helpful in thinking of how you would use your application to communicate this information to others, because then you can have a conversation. Okay, if the room is between this big and like this width and this depth, it turns red. So we know this is not a size that we want to work with. So maybe having these ideas of what is it that you want your app to do, and then working with this already existing examples, you will get a lot of just building a little function, you will get a lot of training, I guess, and then you can probably write your own.
Great.
So this is the advantage of open source community. You have all the applications, all the code available free, and you can just copy the code, change a couple of things, and see what it's doing, and then you will gradually move from their application to your application, like from where you copied the code, you saw the code.
Great. So just from the participants, do you guys, is this all clear what the next step is? Do you have any questions before we break to the next step? Okay. Maybe Arifan, you can talk about like the deliverable at the end of the workshop and like what they should do to like finish the workshop.
Yeah, I sent an email to everyone. So we just want something documentable to tell people what we did for this workshop. Like if CAADRIA asks for something, like what do we show them? Because we're not in person, we're not 3D printing stuff or creating like posters. So let's have slides from each one of you, just one or two, with a visual of what you did, what you learned, and where you might want to take this in the future for your practice. Yeah, that's about it. And if you are indeed in the future going to use this to create artifacts, for example, if you want to 3D print prototypes or something, like, or if you're already doing it, I don't know if you are. We don't know what you're doing with this right now. So yeah, we would like to see some of that too.
Yeah, and I think there's a Pecha Kucha actually on the 30th where we'll present the results of the workshop. So it would be very helpful to have some material which you guys came up with your project.
I think we need some material.
We need some material.
But we really need it.
All right. So with that, just want to thank everyone for joining us for these 3 days. It's been a lot of fun. It's been a lot of fun for us to actually put together this workshop and engage with the community. It's been a huge learning experience. So we're really excited to see where you guys take this. And also with this like last step or anything, feel free to reach out to us on Discord. We're like available all day to answer your questions or help you with your project.
I just gave
just engage us.
Examples and links of various data sets to a couple of participants yesterday on Discord. So if you want, you can definitely reach out. And for this application thing, if you think that the coding part is very difficult, how can I create a simple application with 100 lines code? You can just sketch out your UI, like you want a button here, you want a slider here, what you want as output, what you want as input, what are the colors. You can just draw it in, like, you can even draw manually or in some softwares, and then send it to us and we'll guide you how to create applications on that.
I mean, while we're already here, why don't you tell us now what you're trying to do? And by the way, software isn't any different from architecture. There is a sketching process involved. Oh, by the way, the reason why this is called a sketch, P5.js, like code is called a sketch because it is precisely what a sketch is to designers. This is like disposable. This is has like, it's easily modifiable. You can quickly generate lots of them and then just like rapidly iterate through them and then throw them away and make new ones. That's actually where they got the name sketch from. I think Sejal knows about this, like Casey Reyes and who else was it? I think they were basing it off
Ben Fry.
Yeah, were they basing it off Anna Goldschmidt's research?
No, they were John Maida's students. So okay. John Maida said that they surpassed him. He said it's not often that your students do something more important than you, and then that they did they changed the game.
Yeah, so this is what it is. It's a sketch, but then of course, like you can also like actually sketch, like here's what I wanted to do with this data, connect it to that, and then like draw a picture of what you want to achieve. So why don't we like have a discussion right now? Like tell us what you're expecting, and then we can and just like share. Is anyone willing to do that?
I think what we can do is like we can give them 15 minutes and they sketch and put it in Miro or even Present, and then maybe we can guide us if they are shy to talk and present, they can even add it to the Miro board.
Yeah. Or if you find Miro difficult, just
tell us.
Sketch it on paper and send us a text on Discord. Whatever works for you.
we are also learning. Like, we are not super professionals in all these, like whatever softwares and web applications we showed. We are also learning more with you.
Maybe we'll call people out. So maybe Faochen, what are you thinking to do for your project?
So so currently for this workshop, I learned two things. So first one is about the machine learning, and second one, and this is my first time to learn or hands-on with JavaScript.
Yeah.
Yeah, and I learned a lot. Even though I keep muting my
What your classifier identifies this image as. So it would be more similar to San Francisco to Tokyo, or to, like, that would be an interesting exercise.
Yeah. And how are the results? Like, it says category Bandung and confidence is 0.99. So is it correct or is it misleading?
I think it's still misleading. So I think it needs more data to train. So yeah.
Yeah, absolutely. That's what you learn, right?
Awesome. Yeah, the very fact that you figured that out tells us that we've been kind of successful.
No, but I mean, you could also imagine, like, instead of manually getting the images, the next step is to write like a little program that could just extract, like, crawl across a map and just extract like hundreds of images for training.
Yeah.
Yeah, I think you reached out to me on Discord asking, like, is
Yeah.
it a way, there is a way to automate this thing? And
Yes.
to my knowledge, I may not know
There
it, but
definitely is. There
yeah,
definitely is.
definitely there is.
But
Actually,
there is,
that's
right?
what
From Google, the Google Maps. What is this? This is not Google Maps, right?
That's actually what I was doing on Mapbox when I was writing the code for like tiling the raster terrain. It was like crawling across a map and then extracting images. So you could take that sort of idea. It takes a little bit of knowledge of Mapbox though. But basically, you can like fly around a map based on the coordinates and like go tile to tile and like get the image.
That's a good idea.
Yeah, we could share. I could share the link. I mean, it's maybe a bit more advanced, but I could show you at least, like, I could point you in the right direction.
Yeah. And the journey of building such kind of application starts with getting it wrong. So it's good that you learned how and why it got wrong. So you said, like, it needs to have more data and more specific features of each city. So you can, like I said, you can analyze what's getting wrong in the visualization.
Like this one. Can you see my screen now?
Yeah.
Yeah. Actually, this image I took it from somewhere in South Korea, but it said that it's 99% sure it's located in Bandung, which is totally wrong.
Oh, okay.
So yeah. And also Patrick, I already add some line codes to
No, but what's
upload
interesting
the
is
image,
that
but it still doesn't work. Maybe I need to add more function to it.
Yeah, it's excellent
What's
that
in-
you figured out how to add the button. Nice thing.
what I think is interesting here is that even though these images from South Korea, there are between San Francisco, Kyoto, and Bandung.
Yeah, so as I said, you need to fool the machine, and you're successful in fooling the machine and analyzing what's getting wrong there. So it's a good start, actually.
Thank you very much. So I will stop sharing my screen.
Thanks. Maybe Dominic, you can tell us. Sorry to call you out, but you've been engaged.
Yeah, the engagement was very high.
Yeah.
The 3 days was very interesting. They were very interesting. Unfortunately, I didn't have time to finish my project because I was pretty swamped with work and try to manage my sleep in these days because now it's like 2:30 a.m. In here. So
Okay.
try to manage this. But I learned how to connect the data to an application on the web. That was crucial for me because more or less I work already with pandas. I knew a little bit of machine learning, but the connection with the visualization with JavaScript, I was missing it a little bit. I have some experience with JavaScript as well, but you show me how to decompose the full process in small pieces, and I find a lot of links in this, so it was very, very helpful.
Yeah, also there is the last line of lab notes says that there is also a reference file, and the reference file has all the getting started material of what we didn't cover, like say Tableau or the dashboard, which RFN talked about. So I've mentioned all the getting started links from the basics beginners in that reference file, and you can certainly visit that.
I appreciate also the Medium article that Arfane was sharing yesterday. It was very interesting as well. So a lot of input, a lot of energy. Very nice.
Thank you.
Thank you.
Thank you.
Who else? Who else can we call out? Ervin. I know that's not your style to call people out.
I used to do that in class.
Really?
But we're not in class. We're among peers.
So. That is true.
Actually, Guanchi, you had a interesting approach of machine learning. You wanted to use the image segmentation via the PSP net. So did you find any success?
Well, I'm so sorry. I was a little busy yesterday, so I think I will catch up at the afternoon of the day, and I think I will provide something before the end of the CAADRIA meeting. So really thank you for the workshop. I really get some new ideas from the workshop, such as I really know some new things from your tutorial, such as the Google Colab, because in my maybe I have some experience about coding. So normally I just use the Jupyter notebook, and during the installation, it is really common to meet different errors, such as sometimes it's hard to install any packages or libraries. So I just tried the Google Colab yesterday. It is really convenient. Such as I haven't used the P5.js for several years, and it really bring me some new ideas. So that is how I can use it in some architectural projects. So I can combine the machine learning algorithm into the website using the P5.js. So I think I will try it afternoon. So really thank you for providing some new ideas. Really thanks.
Yeah.
Thanks.
So that's what Google Colab is all about. When someone doesn't have any Python softwares or web editors installed, you can simply share your notebook link with them and ask them to run the code in Colab.
Yeah, it's true.
Also, it's very useful for deep learning. You don't need any additional GPUs or any high-end laptops. Google Colab does all the work for deep learning. You can train like.
Yeah, I will try to figure it out. Thank you.
Yeah.
Okay, wonderful. So I think we can wrap up unless there's any final thoughts.
And please reach out to us if you have any questions. Don't be shy. We are also like you, learning things from your end too.
Okay, thanks everyone. It was a good workshop. Excited to see what you come up with, and we'll see you on Discord.